Hey guys, Mr. Jenkins here with lesson 7.5, and this is a pretty cool lesson about exponential and logarithmic equations. So your learning target would be just simply put, you can solve exponential equations, meaning equations with the variable and the exponent, or with a variable and the exponent, and also equations containing logarithmic expressions. With that, that's pretty simple and straightforward, so let's go ahead and get right to it. So when you're solving exponential equations, the kind of property or principle that we use is this, okay? So basically what this says is if I have a common base, in this case called b, then we can set exponent equal to exponent, okay, which I think obviously makes sense. So like an example 1 here, we have base 2, so we can just set exponent equal to exponent. So that says 2 to the x plus 6 equals 2 to the 4x. So we're just going to say x plus 6, if my screen can catch up, equals 4x, and then just solve that just linear equation. So what we end up with is 2 is equal to x, right? And then you can always check. So if I plug back in, I get that this side would be 2 to the 2 plus 6, so 2 to the 8. This side would be 2 to the 4 times 2, so also 2 to the 8. And we know, without really figuring out what 2 to the 8th is, that 2 to the 8th is equal to 2 to the 8th. All right, so next one's a little bit trickier. It says 27 to the 3x equals 81, okay? So in this case, we do not have a common base, right? We do not have a common base, but we do have the ability to rewrite in the form of a common base, all right? So we know that 3 to some power equals 27, and 3 to some power equals 81. So that would be your common base that you'd want to use. So what we're going to do is rewrite 27 as 3 cubed. And we want to rewrite 81 as 3 to the 4th. So now that I have my common base of 3, I can set exponents equal to each other, right? So my actual exponent on this side would be 9x. Think about your exponent properties. It's more straightforward on the other side, just 4. So we get x equals 4 over 9. And let's go ahead and just check that, all right? So since I have my calculator pulled up, I'll just type 27 to the power of 3 times x. So to the power of, and then I'm just going to type 3 times 4/9. And you can see that that's equal to 81, which tells me that my solution is correct. All right, so those are some basic kind of principles. Now we're going to solve ones that don't have a common base. In other words, if we look at example 3, there's no power of 5 that's equal to 130. And obviously we can't break down 5. So let's go ahead and just look at this. All right, now you can follow this step-by-step process, and that's fine. But really, I think the easiest and most straightforward way to think about this is write this exponential equation as a logarithmic expression. So this would mean log base 5 of 130 equals x. Right? Remember, the logarithm is the exponent. Okay, so 5 to the what power equals 130? Well, we learned last lesson that we can use this change of base formula to answer this, right? So we know if we look back at 7.4 that this would be equivalent to log of 130. Now we're changing it to that common base of 10 over log of 5 would be equal to x, and I'm running out of space. So I can actually punch that into my calculator. That's why I do that. So let's go ahead and see what we get. Log 130, close parentheses, divide by log of 5. And we get, it says round to the 4th decimal place, so that's what I'll do. You'll have to pay attention to the Math Excel or whatever you're doing, rounding directions. So 3.0244. 3.0244. And again, you can always check, is my answer going to be exact here? No. If I want it to be exact, I can just do 5 to the power of, and then do insert my answer. And then I see that it is 130. So 5 to the power of this exact number is equal to 130 by the change of base formula. Okay, looking at the next one, the first thing you'd want to do is move over the minus 24, but I'm going to skip that one because there's a calculator issue in example 5 that I'd like to address on the video. All right, so what we have in this case would be that if we thought about a logarithmic expression, the log base 2 of 7 is equal to 5x plus 4. All right, so let's evaluate this side using the change of base formula. So that'd be log of 7 over log of 2 equal to 5x plus 4. All right, so I'm just going to type that in. Log of 7 divided by log of 2, which is equivalent to this number right here. Now, you want to be careful here because we don't want to round until the very end. All right, so I'm actually going to just write down 2.807 ... In other words, I'm not rounding my answer until the very, very end. Okay, so instead of deleting this in my calculator, I'm just going to go ahead and solve for x. So first thing would be minus 4. So I just hit minus 4. That'll take 4 off my answer, so that'd be negative 1.19 something. Equal to 5x. Then we divide whatever's left by 5. So just hit divided by 5. And this way I'm not going to round until the very end, right? If you round in all 3 of these steps, you get further and further from the right answer every time. And then Math Excel won't accept it. So I'm sure you guys will have questions about that, but that's how you handle that. Don't round until the very end. All right, so then we have negative 0.2385. Rounded to the 4th decimal place. It's approximately equal to x, right? And then you can always sub back in to check. All right, so let's see. I will let you guys look at the notes for the word problem, but I suggest maybe you give that a shot. Maybe we'll have an Ed puzzle question about that. We'll see. All right, but I wanted to get to the logarithmic equations. And basically, you're going to have 2 types. There's a type that has 1 logarithm in the equation, which we see in examples 6, 7, and 8. So let's go ahead and start with 6. Now, these look like they might be tougher than the last examples, but they're actually easier, okay? So I'll show you why. All right, so remember, again, what this means, right? If it just says log and no base, this means base 10, right? It's understood that this is base 10. And it really wouldn't matter what the base is because watch what we end up doing, right? So if I think about this as an exponential equation, this just means 10 to the third power, 10 to the third power equals 2x plus 4. Well, that's pretty easy because all we have to do is evaluate what's 10 to the third power. So that'd just be a 1 with 3 zeros. So 1,000. Then you just have just a simple two-step equation, right? So minus 4 to both sides, we get 996 equals 2x. Divide by 2, and we get 498. And again, equations are nice because you can always sub your answer back in, right? If I sub in 498 there, do I get the right answer? And the answer to that question is yes, you do. All right, so I'm going to skip 7, but I will say, notice about how would example 6 differ from example 7? Do those parentheses make a difference? And the answer is yes. You can look at the filled out notes, but on this one, it's just log base 10 of 4x, and then the minus 3. So you'd want to start by adding 3 to both sides to move that over there. Okay, and again, that's in the notes. So I will show just one more of these. So let's look at the next example, which means 10 to the power of negative 1 is equal to 2x minus 8. These are nice too because they make you bounce back and forth between logarithmic and exponential. That lets us not lose sight of, what these logarithmic expressions mean. Now we can evaluate that. That would just be equal to 1 over 10, or 0.1, if you prefer. Might be easier to write it as 0.1 in this case. So add 8 to both sides. That would give me 8 1/10, or 81/10, or 8.1. Then we're going to divide both sides by 2. So that's going to give me, in this case, 81 over 20, or an equivalent decimal. All right. So one more type of problem you're going to see is what happens if we have multiple logarithms in an equation. So basically, you need to be able to, this is your only additional step, right? So you're going to get all logarithms kind of to the same side, and you want to write them. You want to use our properties of logarithms to write as a single logarithm, okay? All right, so I don't know why they just give us log base 10 here, but that's okay. So let's just look at the first one, which would give us, let's go ahead and write this coefficient as an exponent, and then we'll go from there. So this is equivalent to log of x squared. And then your rule for when you add exponents together is you've multiplied the bases. So this is going to be equivalent to log of x squared times 4. Or 4x squared. All right, then we go into exponential form. So that's going to give me 10 to the power of 3 equals 4x squared. Then we just try to solve. So this side would be equal to 1,000. And then the first thing I want to do is divide 1,000 by my coefficient of 4. I know this is a quadratic term, but since we don't have that bx term, we can just solve using square roots. So that's what we'll do. So 10 to the third, or 1,000 divided by 4 is 250. The only thing you don't want to forget here is to do your plus or minus. So x equals plus or minus square root of 250. And since we've been rounding to the nearest, well, let's see. Trying to think of the best way to write that. We could write that as a simplified radical, but yeah, I'll leave it as a simplified radical, and I think it's worked out as a decimal on your homework. Okay, so we could also write that as, more specifically, plus or minus. That'd be equal to 25 times 10, so 5 square roots of 10. Or it ends up being like 15 and change. All right, maybe do one more. Let's look at example 10, and then, yeah, we'll call it a day, okay? So my rule here when I subtract exponents is to divide the power. So we want to write it as log base 10 of x plus 3 over 4. And then from there, we can jump to exponential form. So this would be 10 to the second power equals this. So 10 squared equal to x plus 3 over 4. This is equal to 100. So first thing we'd want to do is take times 4 to both sides. So that's going to give me 400 equals x plus 3. Then subtract 3, we get 3, 9, 7 equals x. Oh, so there was one more thing I kind of skipped over in this next part. So actually, my answer is incorrect. So this will go back to, and we'll finish on this thought. Let's check both of these answers and see what happens. All right. So I'm going to go back to my original equation and sub in this value. Okay. So let's go 2 log and then of x. So let's use positive 5 square roots of 10 first. Close my parentheses plus the log of 4. And we get 3, which is what we wanted. So we know the positive works. Now watch what happens if we do the negative version. Easy to forget, like I just looked at my notes, or I wouldn't have thought of this, but when I do negative 5 square roots of 10, plus log of 4, I get an error. Okay, that's because in this case you can't do the log of a negative. You can't do the log of a negative. So think about why that might be. Why can't we do the log of a negative? All right. So just to correct this answer, we'll say negative 5 square roots of 10 is, remember we call that extraneous. So my actual final answer is 5 square roots of 10. All right, so anyways, we'll review this stuff a lot. I know this is a lot thrown at you, 7.4 and 7.5, kind of some new ideas, but you've been introduced to it, and now we will review. That being said, make sure you're staying up on everything. Make sure you're working ahead so that you can take advantage of those Q&A days, etc. So thanks, and have a good one.